Have you ever wondered how tight you should go when you're tightening a screw or a nut or any kind of fastener? Well, the torque wrench is a tool that lets you measure the torque that's being applied for reliable connections that don't vibrate loose, but also don't break the bolt off. Today we're going to look at the tool, how to use it, and some common mistakes. So let's find out what everybody's torquing about. Hello, I'm John Leeman, the owner of Leeman Geophysical. And today I'm going to talk to you about torque wrenches. So torque wrenches are a tool that a lot of home users or even lab users don't have, but it's not that expensive and it's really handy to have because it lets you tighten a fastener to a prescribed amount of torque and not break it off or not under tighten it. So I am definitely a tool collector, if you will. I counted just a little over half a dozen torque wrenches that I've got scattered around in various places. I carry 3 different ones in my truck, as a matter of fact. All of the torque wrenches are going to do the same job, but in slightly different ways, and we're going to talk about that. But fundamentally, you can set a torque on all of them, and they'll let you know through some sort of feedback mechanism when you've reached that torque. Now, if you under-tighten a fastener, maybe vibration could make it work its way loose, or it might not clamp enough and cause a leak on whatever it's supposed to hold together. Whereas if you over-tighten the fastener, you can break it off and have to extract it, or you could actually warp what you're fastening if the bolts are strong enough and cause a leak that way as well. So proper torques are really crucial, and as you'll see, they're not that hard to achieve. When you go to the store to get a torque wrench, there are various types, and I've got most of those types here, not all of them, but the first and most common is the click type torque wrench. So this torque wrench has a breakover in the head that when you reach the torque, it's going to make a little click and you'll feel the wrench handle give. So this is the most common. It's probably the least expensive generally as well, or at least expensive common one that we see now. And they do just fine, though they can be a little bit tricky to set until you get used to how to read this scale. But you can generally feel them pretty easily. The click is audible most of the time unless you're in a really noisy environment, but these are fine torque wrenches. Now, there was a type of torque wrench that you used to see pretty commonly that was a beam torque wrench where there was a scale and a pointer that showed you the torque you were at. I never really liked these because you had to be applying the torque and trying to read this scale at the same time. And when you're working on equipment, you're not always in the most convenient position to do that, especially if it's something like a car. So I didn't like those a lot. I haven't really seen them on the market much anymore. They've been replaced by all of these now that they're a little bit less expensive. So there's also a split beam configuration, which this torque wrench also makes a click when you reach the maximum load, but it uses a little bit different mechanism inside. Instead of having a spring that we wind tension against, this has a beam that differentially measures the strain on the head, and it's set using a little window. So this is a little bit easier to set. They're a little bit more expensive than click type torque wrenches. They're fine. I don't have a strong preference for this over the other type, other than they're maybe a little bit easier to set, as we'll see in a second. But overall, this is a pretty nice wrench that you can pick up again for under $100. And then there's digital torque wrenches. These are obviously going to be one of the more expensive options. They let you set any setting. So these you're kind of dialing in something that looks pretty close on the scale. With a digital torque wrench, you can set the exact torque that you want, and most of them will beep or flash lights or do some combination thereof to show you that you're at your desired torque. They also have some more advanced features that we'll talk about that you can only get with a digital torque wrench, but they are going to be the most expensive option. For example, this torque wrench at the time of filming this video was about $170. You can also get an adapter, which I don't have any of these, that is a digital torque wrench that goes in line with just your normal ratchet. So then you can crank down and see and get an audible alert using a normal ratchet that you already own. I like having the dedicated tool because this is something that you take generally very good care of. You want to keep them safe and generally are a little more careful than you are with your normal ratchet. And also sometimes you just don't have space for an extra block on the end of a ratchet if you're in a tight situation. Again, anytime I'm talking about tight situations, if you do anything with a car or hydraulic system on your lab apparatus. Generally, those are designed not necessarily for serviceability. So when you're buying your torque wrench, you need to decide which type you want to buy. You also need to know which drive you want to buy. For example, this torque wrench is a 1/4 inch drive, so it takes 1/4 inch sockets and hardware. If you're not familiar with drive sizes, we have a whole nother video that talks about ratchets, sockets, and all the fundamentals there, and I highly suggest you go check that one out. So this is 1/4 inch drive. My digital and split beam here are both 3/8 drive, and then this big torque wrench here is a 1/2 inch drive torque wrench. So why all the different drives? Well, it has to do with how much torque you're applying to the fastener. Smaller drives can only apply smaller torques before the drive itself breaks. So these torque wrenches, in fact this 1/4 inch one here, is calibrated in inch pounds because it's for very, very low torques. It tops out somewhere in the neighborhood of 15 or 20 foot-pounds. Whereas my 3/8 drive split beam starts at 20 foot-pounds and goes up to 100. And my 1/2 inch drive goes all the way up to 250 foot-pounds. So we use this on really big things like changing chucks out on our CNC lathe or large tires on heavy equipment around here, whereas this is for more delicate tasks, and these are in between. I would say I use the 3/8 inch drive most every day in terms of lab equipment, working on my vehicle, general maintenance. 3/8 is probably the best bet, but if you're dealing with really small fasteners, then 1/4 inch might be what you need. Another advantage of the digital torque wrench is though my split beam 3/8 drive only goes down to 20 foot-pounds, this goes all the way down to, I believe, around 5. So I can get a lot wider torque range with the digital torque wrench than I can with the mechanical. Now, of course, all of these come with a certificate of calibration. We'll talk a little bit more about calibration later, but they're going to be reasonably accurate, which is really all we're looking for when we're torquing bolts. Okay, so now we're going to talk about how to set torque wrenches, and I'm going to start with probably the easiest, which is the digital torque wrench. On this particular torque wrench, I just turn it on, and then I use the up and down buttons right here to set my desired torque. Say I want 42 foot-pounds. There we go. This also has memories built in, so I can save different torques that I commonly use. If I've got a few different fasteners that I commonly use, I can save them in a memory, so I don't have to dial them in every time. So pretty nice feature for the digital torque wrench. It's almost impossible to set it incorrectly. Now let's look at the split beam. So on this, I've got a little window right here that shows the torque that it's set to. And there's a scale here showing me the range and letting me convert from foot-pounds to Newton meters. So I just flip this little lock down. You can see the scale rotating in there. I set it on the torque that I want and lock it in. Now, one thing I will say about this particular torque wrench, I don't know if all split beams are like this, but this one in particular, when I put that lock back on, sometimes it does change the value here slightly and I've got to set it again. So that's a little bit annoying. One thing I do really like about this wrench though, is the head that swivels ever so slightly to help me get into difficult to reach spaces or just get that socket on before I straighten everything up. Okay, now we're going to go on to the traditional click style torque wrench. Now, this torque wrench is probably the most difficult to set. As you'll see, there's a scale here that has the numbers and lines, and you have to follow the line down, and you twist the handle to adjust it up and down. So for example, I'm at 120 foot-pounds, and I can rotate it until it locks in to the 0. Now I'm at 130. It's a little hard to read. It can be very finicky until you get used to it. It's not great if you're in a not well-lit area. So these torque wrenches are probably my least favorite to set, but again, they're going to be the least expensive. And once you get used to it, it's not too bad. Now this torque wrench had 10 foot-pounds per revolution of the collar. On the other hand, my 1/4 inch drive torque wrench has 15 or 20 per revolution, in this case inch-pounds. I've got a 3/8 drive that has 15 foot-pounds per revolution. So you need to make sure that you pay attention to the scale and get it set right. So now you know what the torque wrench is and how to set it. We're going to put one to use. I'm going to start out with my split beam. We'll take our socket or driver and snap it on. Again, if you need a refresher on different drives and how this works, go check out our sockets and ratchets video. In this case, I'm using a hex driver, and I'm going to set my torque and lock it in. Now I'm ready to go. I'm going to engage my fastener and tighten until I hear and feel the click. Right there. Now, generally, I go ahead and click it a second time. There might be a tiny bit of movement on the fastener, but it's not going to be that critical, though purists would argue that it should be one click and one click only.
One ping only. I get it.
But that lets me know that I've reached that set torque and I'm good to go on that fastener. Now remove this and go to our digital torque wrench, turn it on, and I'm going to set it to the same torque. And we'll engage this fastener. Okay. When I get close, we see that, so that means we're close, and when we hear the red light and constant tone, we're at torque. All right, right there. So that's at 20 foot-pounds as well. I'm gonna take this wrench and check it. We don't have a calibration stand, but checking two of them against each other is a pretty good check. I could increase this to 25, and now I should get a little bit more rotation on the fastener, and then it clicks. So we know that these two wrenches are in pretty good agreement. Again, you can get these calibrated, and in fact you should if you're using them in a life-critical application, either once a year or every 5,000 clicks, whatever the manufacturer recommends or your industry dictates. Overall though, we generally compare our wrenches to each other, or maybe we might try to get one of those inline adapters to compare in the future. You can buy calibration standards for around $1,000 as well. Overall, we haven't found any of our wrenches to drift very much over about 5 years. So finally, let's talk about care for your torque wrenches. Now we said that you can send them out to get them calibrated, but a lot of people don't. Most torque wrenches still have the original certificate of calibration that came with them, unless you're in something like aviation where it's mandatory. But there are some things that you can do to make sure that your torque wrench has a long life and stays in calibration. The first is don't drop it. And if you do drop it from any significant height at all, or even just knock it off the bench, I would at least check it against another torque wrench and potentially send it off for calibration. These are sensitive instruments. The second thing is, and this one may be a myth, though it doesn't hurt anything to do it. If you have one of these wind-up click torque wrenches, store it at 0 torque when it's not in use. So I've backed off so there's no tension on that spring and locked it down. Now there is a spring in here that you're applying force to when you're setting the torque, and the idea is over time, when stored at a high torque setting, that spring is going to relax some and you will have an incorrect torque value. The Torque Test channel has a really good video on this where they've had torque wrenches that have been set at high values for a long time, and they found very small amounts of drift, nothing that was really outside of calibration or anything to worry about, but they did see a little bit of a trend, and it doesn't hurt to do it, so most of the time I go ahead and back it off. Keep your torque wrench clean, because anything that gets in that mechanism can cause bad values when you're torquing, and for that I recommend keeping it in the case. Normally these blow molded cases that come with tools are worthless and they're the first thing that I throw in the trash, but I keep all of my torque wrenches in their original cases, and that protects them from bangs and drops, as well as keeps them free of dust getting in the mechanism. So hang on to those. The biggest thing that you can do, in my opinion, to damage a torque wrench though, is to use it as a breaker bar. So some torque wrenches, for example, this split beam, they don't even have a reversing lever. This can only be used to tighten. Now that has some downsides, because let's say I have left-hand threads where turning the fastener left makes it tighter instead of looser. Can't really torque that with this instrument. Just because the torque wrench has a direction reversing switch like a ratchet doesn't mean you should use it to loosen things and take them off. This is really for tightening a left-handed thread. If you're loosening fasteners, especially if they're very tight, use a breaker bar or a ratchet. Don't apply all that force to your torque wrench. It's a very quick way to ruin one. Now, one of the biggest debates that you'll see online is about lubrication to the threads. So if a bolt just has a torque spec of, let's say, 35 foot-pounds, and that's all it says, that torque spec is designed for a clean, dry thread, meaning no lubrication. If we lubricate the threads, it reduces the friction significantly, and that's actually where a lot of our energy when we're torquing a bolt is going into, is overcoming friction, and we can over-tighten the fastener. Now, there are some fasteners, especially in engines for automotive applications or aerospace, that say you need to apply assembly grease or motor oil or anti-seize lubricant to the threads and then torque them to a certain torque spec. So you should follow the manufacturer's recommendation for whatever you're working on, but if there's nothing else specified, don't put lubricant on the threads. Another consideration that I see a lot online is if you're using something like a crow's foot that extends off the end of the torque wrench to get on something that you can't get a socket on, let's say, and they say, well, you have to account for that. And it's true, it does add a little bit of length, and we know that torque is a length-dependent quantity, and our torque wrenches are calibrated for the length that they're built at. So yes, technically you should add that in and do the calculation yourself. It's not a hard calculation to do, and I'll link a video that talks about this, but really the crow's foot doesn't add that much length. The main thing is just trying to keep everything as close to the length of the torque wrench design as possible. So if you're using that crow's foot, maybe run it in this direction, because then we stay very close to the baseline the wrench is designed for, versus having it sticking off the end. Things like extensions and universal joints certainly can cause slight variations in torque as well, but sometimes they're unavoidable when you're trying to get into a tight spot. So as you can see, applying proper torque to a fastener isn't hard, and it can be the difference between just putting something together and having it potentially fall apart, or putting something together and having it perform exactly as designed. There's a reason that this is used on airplanes, and it can be used in your lab too, for not a lot of cost or effort. So I hope that you found this tutorial useful. Don't forget to check out our other lab lessons and send this along to those that you think might find it handy, like graduate students in your group or others in your industry. So that's it. Now you know what you need to know about torque wrenches, so you can go out into your lab or onto the shop floor and perform maintenance and assembly in a safe way. There's a reason that this is used in aerospace and critical life safety industries, because it works. It makes sure that the job is done properly every time, and it's not that difficult or expensive to do. So I hope that you found this tutorial useful. Don't forget to check out our other lab lessons and share this with anybody that you think needs a little bit of torque talk in their life. Thanks for watching, and don't forget to hit like and subscribe to stay tuned with updates. And if you need precision equipment for your laboratory, whether it be custom or off-the-shelf measurement, don't forget to check out our website.